All right, in this last problem, we are going to carefully graph this rational function. Now carefully, I don't want you to plot, 25 xy pairs. As long as we get the asymptotes correct and the shapes of the graph and basically have the individual shapes in the right component of the graph, that's what I'm looking for. You'll see what I mean. All right, so first thing we're going to do is find the asymptotes. So to find the vertical asymptotes, we set the denominator equal to 0 and see what we get. So that means x squared equals 9, so x equals plus or minus 3. So x equals 3, x equals negative 3 are the two vertical lines that represent our vertical asymptotes. So I'm going to go ahead and draw those with dashed lines as usual for asymptotes. So we basically need to get some values in each of these three sections, this section, and this section. But let's first finish our asymptotes. Let's do the horizontal asymptote, which I will right over here. Notice that the degree of the top is 2 and the degree of the bottom is 2, the max exponent of the x. So how do we get the horizontal asymptote? Y equals the coefficient of the x squared over the coefficient of that x squared. 2 over 1. So y equals 2. Once again, it's this 2 over this 1, giving us 2. So the horizontal line y equals 2. So before we even start plugging in a few points, we can expect that the graph is going to look something like, in this section, it's going to look something like this. Or like this, one or the other. So really 2 points might be sufficient because it'll tell us whether it's up here or down here. And again, as it gets closer to this, it's going to go, as x gets closer and closer, it's going to go up, 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 up without ever touching it. Or if it's down here, it'll go down like that. And in the horizontal asymptote, it's either going to get close to it from the underneath side or from the upper side. Similar over here on the left, it's going to either look like this or it's going to look like this. In the middle, there are a couple of options. It could look something like it. It's not a parabola, but maybe an upside down parabola. It could look like a right side up parabola. Or it could even cross. It could cross here and go, have this as an asymptote, and then as it goes down, come and have this as an asymptote. So there are only a few different possibilities, really. All right, well, why don't we do the midsection first? The midsection, because I want to find out what f of 0 is. And it turns out that f of 0 is 0, right? It'd be 0 over negative 9, which is 0. So that means we're right here. So I think I'm going to plug in negative 2 and 2 and see what we get. Oh, interesting. I just observed that this is what we call an even function, right? If I plug in, pick a number, if I plug in 10, well, if x is 10, it's going to get squared to be 100. Same here. If I plug in negative 10, it's going to be squared to get 100 or squared to get 100. So I really only have to plug in positive values because it's an even function. We can just use the mirror image, though, over the y-axis to get the other half of the graph. That's not always the case, but it is with all even functions. As long as this is an even function, all the exponents of the x are even. So clearly, if you put in a positive 3 or a negative 3, you're going to get out the same height, the same value of the function. So let's just do positive numbers. So let's do, say, I kind of want to do f of 1 and f of 2. I think I'm going to. Let's do f of 1, which would be what? 2 over negative 8. 2 over negative 8, which is negative 1/4. Okay, so 1, negative 1/4. And this gave us 0, 0. So now I'm going to do f of 2, which will give us 2 squared is 4. 4 times 2 is 8 on top. And then 4 minus 9 is negative 5. That's negative 1 3/5. So 2 gives us negative 1 3/5. Let's plot those. We got 0, 0. 1 gives us negative 1/4. 2 gives us negative 1 3/5. So a little more than negative 1 1/2, a little farther down. And now let's go ahead and use the mirror images of those 2 points. All right, that gives us a good feel. It looks like it's going to go just like this. Never touching that vertical asymptote. The mirror image over here, never touching that vertical asymptote. All right, so we're done with the middle section. Now let's do the right section, and again, we'll be able to use the mirror image over here. So I'm going to choose 1, 2, 3, 4. Let's choose 4 and 10. 4 is, well, we'll see which way it is. Let's see. So f of 4 and f of 10. F of 4 is going to give us 4 squared is 16 times 2 is 32. Plug a 4 into the bottom and you get 16 minus 9, which is 7, which is 4, 28 and 4/7, around 4 1/2. So that's like 4 and 4/7. F of 10 will give us on top 200. 100, 10 squared is 100 times 2 is 200. On the bottom we would get 100, 10 squared is 100 minus 9, which is 91. And that is 2. 2 times 91 is 182. And 18 over 91. So that gives us 10, comma, 2 and 18 over 91. Notice that that's approximately 2 and roughly 20 over 90, 2/9 maybe. So not too far from 2.2, something like that. So we don't have to be too precise on that. But let's get to 2. Let's see, f of 2, no, f of, let's see, what do I want to do? F of 4, that's the one we didn't plot yet. F of 4 is 4 and 4/7. 1, 2, 3, 4, and a little bit more than 4 1/2. Okay, and then f of 10, just go up about, roughly speaking, 2.2. So at 10, 3, 4, 5, 6, 7, 8, 9, 10, go up 2 and a little bit more. And you shouldn't be surprised that it's very close to that asymptote. If I'd have chosen, did I count that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. If I went out to 11, 12, 13, it would be 2 and even a smaller number. Right there, it'd be getting closer and closer. So this graph looks like it'll be like this. Okay, now let's make the mirror image of those 2 points. 10 was about 2.2 roughly, so negative 10. 4, 5, 6, 7, 8, 9, 10 will be right about there. These two are mirror images around the y-axis. And then these two will be mirror images around the y-axis. Put that about right there. All right, so we'll do the same thing over here. And that's a pretty good graph. It's nice because we only had to plug in positive points here because we know that if f of 1 is equal to negative 1/4, f of negative 1 is negative 1/4. Down here, f of 4 is 4 4/7. F of negative 4 is 4 4/7 as well. So we just graphed a rational function.